Jai Hind to everyone. So today I am here to present one very complex topic that you usually come across, that is robot singularity. So we are going to discuss this topic as a part of our syllabus, that is automation and robotics, and subject code is BOE 302. So as a complex topic, I am just going to give you insight of this topic, what exactly robot singularity is. My name is Vikash. I am assistant professor in mechanical engineering department. So before we go into detail of robot singularity, why it is happening, understanding of that is very important, and always this robot singularity derives from the kinematics concept of any robot. So if you see any robot, so it can work on two fundamental things, either it will follow direct kinematics or inverse, sometime it is known as indirect kinematics. So these two things you have to understand very well before we go in depth of robot singularity. So what is forward kinematics or direct kinematics, and what is inverse or indirect kinematics? So a very basic difference that I am going to tell you here, whenever we are saying forward or direct kinematics, what is going to happen here? See, here joint values are written. Joint values means, suppose your robot is articulated robot, so it is having J1, J2 and up to J6 joints. So it is 6 axis robots, that's why 6 joints are there. And if you know the angle of each and every joint, suppose joint 1 is situated at 90 degree, joint 2 situated at minus 90, like that. If joint 6 having value 180 degree. So like that, if you have value of each and every joints, so your end effector basically going to achieve some position that is known as target. So this particular position we are targeting while we are running or while we are operating our robot in direct kinematics mode. Means if angle is given and we are trying to get our target. So that is a basic thing that you have to always remember, from angle to target if we are going to achieve, it means it is a part of direct kinematics. And if we just reverse it, suppose I am having some target here and through robot end effector I am trying to achieve that target, means I am trying to move my robot so that it can catch that particular target. So for that purpose you have different options, means you can go with different angle combination so that you can get your desired results. So here if we are going to reverse the things, means here target or position is known, and what we are trying to drive, angle of the joints. So if we are handling articulated robots, means 6 angle different value you have to find out. And just think of that, if you are part of this first case where angle is known, means each and every axis angle is freezed. So you cannot go, or anyone cannot go to different location, because each and every joint angle is fixed. Suppose I am saying this elbow angle is 90 degrees, so always it will go like this. So if anyone is going to operate this robot, this joint, if suppose this joint is having 90 degree value, so always my target or end effector position will be same. But if I am saying this is my target and according to this I have to change or I have to catch this with the help of different joint configuration, I can go with this angle, I can go with this, I can go with this. So if you notice, this elbow angle is changing with each and every condition. In each and every condition this is changing. So what here I am trying to say, if we are following forward or direct kinematics where angle is given and you have to find out your position or target, it means if any one person is going to operate robot or n numbers of person going to operate, but one thing is similar, only and only one solution, only and only one solution is possible in this case, direct kinematics case, because you cannot play with angle. So, angle is freezed. So, every person who is going to operate robot means they are going to achieve same position always. So, only one solution possible in direct kinematics case or forward, but vice versa, if we go and follow this inverse kinematics case, it means you are free to configure your robot as per your target. So, target is freezed here, or location where you have to carry your end effector is freezed, but you can play with different angles of the robot. So, here if we are going to follow inverse kinematics, so I can say here n number of solution is possible, because if anyone is going to operate robot, it may like to achieve, suppose this pointer is my target. So, anyone go like this, someone go like this, someone go like this. So, in every case our angle is changing. So, there are n numbers of solution possible, and here singularity comes in picture when robot having more than one solutions to go from point 1 to point 2. Like suppose this is our space where I have to move my robot from location 1 or point 1 to point 2. If there is limited solution to achieve this, to achieve that particular trajectory, it means robot is not going to confuse. But suppose you have to consider this inverse kinematics case where number of solution is more than one. So, robot will try to optimize that solutions and try to come up with one solution so that it can follow at least path between point 1 to point 2. But there are certain conditions, mainly 3 conditions are there, where our robot is going to confuse or get confused while we are operating robot in space, how it should move from current location to target location because of so many solutions, and that is the place where singularity comes into the picture. So, like these are the typical like articulated or any kind of robot where links joint configurations are there. So, 1, 2, 3 links are there, 1, 2, 3, 4 joints are there, end effector is there. So, you can play with this joint angle, you will get different positions, and suppose this is our target, suppose this is our target. So, this is one orientation in which I can reach here, but I can also reach with this kind of configuration like this, my robot is achieving the same. So, you can go with different solution, and more clearly you can see in this picture. Suppose this is our workspace where I have to move. So, this is link 1 and link 2. This is joint 1 or joint 2 you can say. So, with this configuration I can go here, I can go here, I can go here. So, there are so many solutions because my target is this orange like area where I have to put my end effector. So, there is different ways in that I can move. So, if you see here in first picture if you observe, it is a case where only and only one solution possible. So, see here this is joint 1, joint 2, joint 3 like that. So, every time our target, our end effector is achieving the same position. So, this is home position if we can say, and this is the target position. So, every time my robot is moving in such a manner where robot is configured with similar angle, but always achieving the same target here. But if you see this picture, every time all joints are moving in different ways, but the target is same. So, here you can say number of solutions we are getting. Either my robot can go in downward way, upward way, or any other way. So here always solution, always you can say solution is more than 1, but here always solution is equal to 1. Only and only one way to achieve this thing. Now coming to the singularity part, as I said, when robot is having so many options and how robot is going to move from one point to another point, that is the place where singularity is going to come. So a robot singularity is a configuration in which robot end effector is nothing but a tool, become blocked in a certain direction because of so many solutions. So let's understand what are these solutions where robot can get confused. So if you see in this picture, there are so many robots, and each and every robot having different like you can say status. Here it is tilted like this, and so each and every time robot is tilting with different angle. Just see this articulated robot that is having 6 degrees of freedom. 1, second angle, third angle, here fourth angle, this is fifth angle, and last this black plate is known as tool where we are going to mount our end effector. So this is a flange plate. So all these 6 axes. Suppose I have to reach here, just focus on slide. Here suppose this is my target and I am going to place this robot like this. So these are the like current joint angles. So I can go like this, I can go like even go like this, I can go like this. So you can say with different, this is the one position and this is another position where joint angle is changing, but we are targeting same thing or same position we are targeting, but with different joint configuration. Let's discuss the type of singularity. So very first singularity comes in picture is alpha 1 position singularity. Why it is alpha 1? Because for defining this singularity, we are taking reference of axis 1. If you see this model is having axis 1 here. So if we insert one plane here at the center of this motor axis, so you will find either robot, this point, this dot that you see here is a black color, this is known as wrist root point. If this wrist root point is going to fall in front of this plane, that is basically overhead area, and this is basically green area and this is red area. If it is falling in front of this, that means we have to check this case where wrist root points located in the intersection of axis in position directly on axis 1. So this is, if you see all planes having this, here it is just in front of this, here it is lying on this, and here it is behind this. So if this is wrist root point, so it is in front of this plane, here it is exactly on the same, and here it is behind this plane. This is the wrist root point. So these 3 cases are there. So if during your operation, if robots comes in this scenario where this plane and this wrist root points come and aligned, so it means robot will get confused where it has to move, from current location to the target location. So this situation we always have to avoid during our programming. Second case is alpha 2 position. Alpha 2 positions means we have to take reference from axis 2. So if you are going to stretch your robot, see this is the position where I am stretching my robot. This is axis 1 and this is axis 2. So this is axis 2 and this I already declared, this is our wrist root point, this black dot. So this axis 2 and this axis wrist root point, if they get aligned, so they are in similar line or similar plane. As you see in this picture, it is perfectly presented in second case where axis 2 and this wrist root points are getting aligned. So because of that, basically again one situation rises, that is basically a singularity condition, and that is known as extended position singularity. In this case also, robot is not able to move in a very fast manner because it is getting confused how robot has to reach from current location to the final location. Now coming to the last kind of singularity, that is known as alpha 5, or it is driven by axis 5. So what is axis 5? First you have to understand, this is 1, this is 2, this is 3, this is 4 and this is 5, where robot is moving at the wrist root point, and this last black plate is known as flange plate, where we have to mount tool. So if I am moving my robot and this 4, 5, 6, 4, 5 and 6 get aligned, so this is straight. If you observe middle thing, so here all axis 4, 5, 6 are aligned. So because of that also robot is facing some problem of wrist root singularity. So always avoid this straight position, either go with this downward or upward position, so that you can easily avoid this singularity. So if you like compare alpha 1 singularity, alpha 2 and alpha 5, so wrist root singularity, in 80% case you will find people are struggling with this wrist root singularity, because if you see look wise it is very good, it is all 4, 5, 6 axes are straight, but mathematically it is very incorrect. So you have to either make it downward or upward, so that it can have some finite solution, it not tend to the infinite solution. So this is the singularity that maximum like falls while we are utilizing our industrial robot for any applications. And alpha 2 and alpha 1, that is none other than extended arm singularity. This is extended arm, where we are going to stretch our robot in a very full manner like this. So it only comes when our reach of the robot is not appropriate. If you are selecting your robot in such a manner where reach is not a problem, then you are not going to stretch your robot full flange. So if your robot is selected according to your application, so you need not to like stretch your robot. So you can also avoid this. And alpha 1, that is overhead singularity. In some welding applications where we are doing overhead welding kind of things, that comes. So these two singularities are very minimum, but you have to only focus on this. If you are focusing and trying to avoid this, means you can easily minimize your overall cycle time. So let me summarize all kind of singularities here. So we have gone through alpha 1, alpha 2 and alpha 5 singularity, and we have seen the comparison between all. Like mostly we have to avoid this alpha 5 singularity during our programming, and this straight case where 5, 4, 5, 6 are intersecting, we have to avoid this phenomena while we are programming. So let's quickly watch one video where basically if you see all kinds of singularity is happening, and while this singularity come across during your jogging, it is trying to avoid that particular position by moving their axis at very high speed. So if you can observe, this is alpha 5 where wrist axis singularities are there. So this is wrist singularity case where all 4, 5, 6 are getting straight. And if you observe here, robot is totally stretched. Sometimes it is also known as shoulder or elbow singularity. This is shoulder singularity, that is overhead singularity in our case. So sometimes in some author, in some books, they are declaring as a they are declaring this as a elbow or shoulder singularity, but you have to go with the base root or the concept how it is happening. So you can easily identify here all axes are straight. So it is wrist axis singularity. In this video, second is basically extended arm singularity. So this is wrist root. Whenever it gets straight, it is moving at very high speed. Second is our extended arm singularity. Here robot is totally stretched. So here second and this wrist root points are aligned. So because of that we are getting some problem in robot. And last one is overhead singularity, where wrist root point is aligned with your axis 1. So this is the last and very popular overhead singularity. It is always due to our restricted work envelope. So you can simulate your things and you can avoid all these problems that comes during robot programming, so that overall program cycle time can be minimized. So thank you for this topic. Thank you all for listening me. So this is all about singularity that we have discussed here, and this is the most common problem that you can easily target or avoid if you are having some basic knowledge about this. So simulation is a one tool where you can simulate and you can easily avoid, or while you are jogging, you can also jog your robot at slow speed, and if such cases rises, you can easily avoid by touching up some new points so that this singularity can be avoided. So thank you for listening me. Thank you all.